find a quiet place to sit or lie and to listen to this audio. Once seated or lying, close your eyes. Focus your attention on your breath. When you're ready, inhale slowly. Let the air fill your lungs. And then exhale slowly. Let the air escape from your lungs. Inhale again, and then exhale again. Notice how your stomach rises as you inhale and falls as you exhale. Rises as you inhale and falls as you exhale. If your mind wanders, don't be concerned. Just gradually shift your attention back to my voice. Now imagine consuming your favourite meal, perhaps a laksa, a pizza, or a Rogan Josh. Imagine the aroma of this food saturating your nostrils as you inhale with satisfaction. Imagine the emotions you feel, the excitement or relief, for example, as you shift the food towards your mouth. Then imagine the sensations you experience as this food touches your lips, your tongue, your palate, and your throat. Try to recreate the flavours in your mouth. Try to savour the anticipation and enjoyment. Part 3. Now shift your attention toward the part of the brain called the hypothalamus. To visualise the hypothalamus, imagine you could drill horizontally between someone's eyebrows into their brain for about 4 or so centimetres. You will then notice a structure behind this point that resembles about 15 jelly beans of different sizes, each lying at a different angle, jammed together. Each of these jelly beans is a distinct cluster of neurons called a nucleus, and each jelly bean has been assigned a different name, such as the arcuate nucleus, the paraventricular nucleus, the lateral nucleus, and the ventromedial nucleus. Now at this time, you don't need to remember the name of these jelly beans or parts of the hypothalamus. You don't need to devote any effort into this exercise. You merely need to follow the instructions and notice how the hypothalamus comprises about 15 or so distinct classes of neurons. Now focus your attention on one of these jelly beans in particular, a jelly bean located at the bottom of this hypothalamus, but towards the centre instead of the front or back. And this jelly bean resembles an arc, like the Arc de Triomphe in Paris. Consequently, this jelly bean, or cluster of neurons, is called the arcuate nucleus. And visualise this arc, or arcuate nucleus, at the bottom of the hypothalamus, embedded within the cortex of the brain. Actually, this arcuate nucleus, or arc, comprises several families of neurons. But to simplify the image, pretend now the arcuate nucleus comprises 2 families or sets of neurons, green neurons and red neurons. The neurons are not actually green and red. However, the image is easier to construct if you imagine green neurons and red neurons overlapping with each other. Now, whenever people have not eaten for a while, the green neurons are activated, and these neurons ultimately promote hunger and encourage the inclination to eat. Whenever people have eaten enough recently, the red neurons are activated, and these neurons stop the inclination to eat. So green symbolises go, or eat more, and red symbolises stop, or refrain from eating. So how do these green and red neurons know whether you have eaten recently? Well, in essence, if you have not eaten for a while, your stomach or intestines produce chemicals that promote hunger, such as ghrelin. And these chemicals activate the green or hunger cells in the arcuate nucleus. If you have recently eaten, your stomach, intestines, and fat cells produce chemicals that foster a feeling of satiation or fullness, such as CCK, insulin, or leptin. And these chemicals activate the red or satiation cells in the arcuate nucleus. At this time, you don't need to remember these details. You merely need to know that some cells in the arcuate nucleus are activated when you have not eaten for a while, those are the green or hunger cells. and other cells are activated when you have eaten recently, the red or satiation cells. The question is, how do these cells affect behaviour? How do these cells influence feelings of hunger? How do these cells influence the inclination to eat? Part 4. These green cells and red cells both send axons to another region of the hypothalamus, the paraventricular nucleus, just above and in front of the arcuate nucleus. You can imagine the paraventricular nucleus in the front half of the hypothalamus resembling a small blob or Pac-Man shape. In essence, the paraventricular nucleus inhibits the inclination to eat. You might visualise the paraventricular nucleus as a judgmental fitness expert that resembles Pac-Man, scolding you, saying, "Stop eating, stop eating, stop eating." So how does the arcuate nucleus, the region that resembles an arc, influence this paraventricular nucleus, the region that resembles a Pac-Man? First, the green or hungry cells in the arcuate nucleus attempt to silence or inhibit this paraventricular nucleus. You can imagine these cells sending axons like leaflets that are designed to gag or stun the paraventricular nucleus. So as a consequence, the paraventricular nucleus can only whisper, "Stop eating, stop eating, stop eating." In particular, the axons that emanate from the green or hungry cells release inhibitory neurotransmitters, chemicals that inhibit the paraventricular nucleus. And these neurotransmitters include GABA, neuropeptide Y, and a Gauty-related peptide. But you don't need to remember these terms GABA, neuropeptide Y, and a Gauty-related peptide at this time. You merely need to observe how the green or hungry cells in the arcuate nucleus inhibit or quieten the paraventricular nucleus, so this nucleus can no longer suppress the urge to eat. Second, the red or satiation cells in the arcuate nucleus attempt to activate or encourage the paraventricular nucleus. That is, the axons that emanate from the red or satiation cells release melanocortins, small proteins that excite the paraventricular nucleus. So these red cells thus inspire the paraventricular nucleus to shout, "Stop eating! Stop eating! Stop eating!" Part 5. But how does this paraventricular nucleus inhibit the temptation to eat? Well, in essence, the paraventricular nucleus inhibits yet another region of the hypothalamus, called the lateral nucleus, or the lateral hypothalamus, on the side of this hypothalamus. Now, this lateral hypothalamus resembles a kidney bean. In essence, when the paraventricular nucleus shouts, "Stop eating, stop eating," it's this region is mainly talking to the lateral hypothalamus. And this lateral hypothalamus releases many hormones and activates many other regions of the brain. So you can visualize this kidney bean producing a raft of chemicals in the blood and sending axons to many parts of the brain. But all these hormones and axons are intended to compel people to eat. So for example, imagine the axons extend from this lateral hypothalamus, embedded within the cortex, really as high as the eyebrows, sending axons to the nucleus of the tractus solitarius in the medulla at the bottom of the brainstem, as low as the mouth. And these clusters of cells in the medulla promote salivation and increase the extent to which food seems tasty. So hence the lateral hypothalamus indirectly promotes salivation. Or you can imagine axons extend from this lateral hypothalamus to the spinal cord, activating neurons that increase the secretion of digestive juices in the stomach and intestines. Or you can imagine axons extend from this lateral hypothalamus to the cerebral cortex, activating regions that increase awareness of the taste, smell, and sight of food. Part 6. Other regions of the hypothalamus also affect the inclination to eat or to refrain from eating. One of these regions is called the ventromedial hypothalamus, a region just behind and above the arcuate nucleus. Now, when this region is activated, people tend to feel their stomach is full. Perhaps while you focus your attention on this region, just behind and above the arcuate nucleus, just imagine the feeling of fullness in your stomach. Try to experience the sensations you would feel after a heavy meal, and then repeat to yourself the term ventromedial hypothalamus, ventromedial hypothalamus, ventromedial hypothalamus.